Alright everyone, I want to talk really briefly about the three chemical buffer systems in the body. Alright, the first one, which you see is we've talked about the most extensively in this course, is the bicarbonate buffer system. Here's our favorite equation. Carbon dioxide and water. You get carbonic acid. It dissociates in water to hydrogen ion and bicarbonate. This bicarbonate can donate a hydrogen ion or it can accept a hydrogen ion. So it makes a great buffer. And we talked about it in the respiratory system. We've talked about how hypoventilation, lower breathing levels, that will cause an increase in carbon dioxide, which will shift the equation to the right. You'll have more bicarbonate and more hydrogen ions too. Hyperventilation, you get rid of extra carbon dioxide, often more than you need, and you end up with less hydrogen ions. So the pH is going to increase for hyperventilation. Alright. Urinary, we talked about bicarbonate because we talked about how hydrogen ion is excreted, how you form then carbon dioxide and water, and it comes back in, and then it's reformed. Carbonic anhydrase transforms it back into bicarbonate, and that hydrogen ion is excreted back out to kind of catch more bicarbonate, whereas the bicarbonate that was caught is then transferred to the blood. Alright, and also production. Remember, we could take a glutamate and pull off two ammonias and end up with two bicarbonates. So that's the urinary system. So bicarbonate buffer system, we talked about it in the respiratory system and in the urinary system. Alright. Phosphate buffer system. Book doesn't have much on it. We don't talk about it much. I think you get a whole paragraph in the book. But H2PO4 can dissociate into H2, oops, that should be a P, not a C. H2PO4. So used to writing carbon for the bicarbonate. Alright, so we see it. It's a lot higher in the cytosol and in the filtrate and the nephron. It's low in the extracellular fluid. It's important, but it's not a huge percentage of the buffering. Alright, the last is the protein buffer system. So we have these carboxyl groups, and they can then go to their conjugate base and accept a hydrogen ion. The one we talked about is in the blood, in the red blood cells, hemoglobin. Remember, we have carbonic anhydrase, transforms carbon dioxide and water into bicarbonate and a hydrogen ion. And the hydrogen ion goes and binds onto hemoglobin. You also really see this a lot in the cytosol. Well, this is the cytosol, but of all proteins. And it accounts for about 60 to 70% of the total buffering in the body. So the protein buffer system, we didn't talk about as extensively as the bicarbonate, but it's very important. We did talk about it with hemoglobin, so you'd want to list that down on an essay. So the three systems: bicarbonate, phosphate, and protein. Bicarbonate, we talked about it in the respiratory and the urinary system. Phosphate, you really see it in the cytosol and in the filtrate. And protein, we talked about it with hemoglobin, but it's a very important component. Right? The carboxyl groups can be, their conjugate bases can then accept a hydrogen ion. Alright, so those are the three chemical buffer systems in our body.